Hello class, in this video, let's take a look at example 5. So please take a second and read it. So they're basically stating that a company produces M&Ms and basically the chances that one of these is actually blue has a 24% chance of this occurring. So the sample has to, we're told that it has 100 M&Ms and they're randomly selected. Now, they want us to find the mean expected value and standard deviation out of the 100 M&Ms. So in this case, we have a binomial experiment. With the following parameters. So n is equal to technically 100, and you technically have a total of 100 trials. Now, to evaluate parts of the binomial formula, you're going to have p. Now, p is actually given as the probability of a success. So for this problem, the probability of success is the chances that you get a blue M&M. So in this case, it's going to be 0.24. And if you have p, we may need q. Q is to find the chances of a failure. So 1 minus the values of p, which in this case is going to be 1 minus 0.24. And please evaluate 1 minus 0.24. I'm getting 0.76. So this is equal to 0.76. So we technically have a binomial experiment with the following parameters. And for most of these, you just need n, p, and q to evaluate any values within the probabilities. Now, let's take a look at the mean. So the mean, it's actually defined, the mean, the standard deviation, and the variance at the beginning here. So page 1, these are the formulas that we're going to be needing for some of your binomial experiments. So in this case, the mean is simply n times p. So let me go back to the problem. So in this case, the mean is equal to n technically times p. So for this problem, it's going to be 100 times the values of 0.24, which is going to give us, 24. And if they want the expected value is also the mean, but with units. So this is n technically times p. And we already found that that is actually the value of 24. So in this case, the expected value is going to be 24 technically blue M&Ms. Remember that all expected values are technically the values of the mean rounded to the nearest integer, but they have to have units. Now, the next portion is the standard deviation. So the standard deviation of a binomial experiment is defined as basically sigma, which is defined as the square root of n times p times q. So once again, I'm obtaining this from page number 1. These are the main formulas that we're using. Let me go back to the problem. And in this scenario, let me modify the values that we're obtaining. So we found that p was basically 0.24. The values of q was 0.76. Now, please evaluate this into the square root. And let me modify. This is from a previous calculation. So you're evaluating the square root of 100 times 0.24 times 0.76. Can you verify that you're getting 4.27, 0.83, which is going to be approximately 4.27. So this is the value that we're going to use for future calculations. So in this scenario, that happens to be the actual standard deviation of the problem. Now, let's take a look at the usual interval, since we already did the standard deviation. And the main question that they're asking here is it unusual to find 27 blue M&Ms out of the 100, and you can technically find it both ways. You will only select one way unless you're told to basically find the probability or the usual interval. Remember that your usual interval, this actually goes back to the original problem. The original problem that we had is that, well, some of these are bell-shaped, so you're still looking within one or actually two standard deviations away from the mean. So if you were to answer this question using the actual interval, you would say that the usual interval is mu plus or minus 2 sigma. So in this case, the values of the mean were 24. So I'm going to change this and adjust it. So 24 plus or minus 2, and the standard deviation that we found was 4.27. So please evaluate that calculation to see if we're matching to the interval. In this case, we're looking at 24 plus 4.27 and then subtract that value. I'm getting the following for my interval. So the smallest value is 19.73 and 28.27. Whoops, I don't think I multiplied times 2. Give me a minute. So 2 times. Okay, please double check. Sorry, I had an error in the calculation. And verify that you're obtaining on the lower bound 15.46 to 32.54. Which, if you were to round, you would say 15. So you would have 15 to technically 33. In this case, blue M&Ms. Now, if you were to evaluate the interval, and you're actually looking at your interval being between 15 to 33, in this case 27 is not unusual. So you would simply say it is not unusual to find 27 blue M&Ms, since the usual interval consists of, in this case I'm just gonna cut and paste. Actually, it's not gonna work. So consists 15 to 33 of the blue M&Ms. Now, a question for like part B, you would only select one way of actually answering it, either the usual interval or the probability. Let's now investigate the probability. Now, let x is equal to, in this case, selecting a blue M&M. Now, what they're asking us to do here is evaluate the probability of 27. So x is equal to 27 of the blue M&Ms. And evaluating it this way, we're actually going to need the calculator and the code. So you would activate the binomial PDF, in this case second and distribution. Binomial PDF. Now your trials represent 100. The probability of success, it's technically been defined in part A. They're saying that it's going to be 24% chance. So in this case, it'll be 0.24. And then the actual selection that we're doing is a total of 27. So 27 successes. And what this code is evaluating is the probability that within a binomial experiment of 100 trials, with a 24% chance of a success, you obtain 27 successes. So please punch it in and see if you have see if you're matching. I'm getting approximately 0.07. Let me just copy that to 4. 0, 7, 0, 4. So in this case, not unusual to find (27) M&Ms, since the probability of x is equal to 27 M&Ms and in this case you're answering that it happens to be greater than 0.05. The 0.05 is technically from section 5.1. So for this particular problem, there is two possible ways to answer the question if 27 M&Ms happens to be unusual to be found from 100, and they both actually agree. Now, they're both going to agree if the histogram for the binomial happens to be approximately bell-shaped. As you work on the homework sections, please check what they want you to do. And on some problems, these two may not agree, and that's because the binomial may not be approximately bell-shaped. Most of them are approximately bell-shaped, but you cannot count on that part.